And wait to see if it's streaming. I'm gonna continue to do the poker software today. Our poker tool. I think I'll put music only for myself today. I got the most used bets and then I put it here and then I saved into this format. And then there are two things I realized. The first one is that isomorphic means that all of the suits have the same frequency. So here it gives me a warning because it says that this is not an isomorphic range because each of the suits has a different frequency, which makes a lot of sense for the same cards. So one thing that I can do, like it allows me to build it, but I think it's better if the ranges are isomorphic, because what I realized is that the most, like a preflop, there is no reason for them to not be isomorphic, and then in the river they can be more isomorphic because there's a lot of variance in the different kinds of boards, and then obviously the suits are gonna matter in the hand. But here, the reason why they are isomorphic is obviously because the data is from a bunch of different players. But the one thing that I'm not really sure, and that is also bothering me, is that this is another reason why I'm not really sure, 100% sure if the data is correct or not. Because, like, even if there are variance because it's different players, I guess it can be correct because. And for something like aces, for example, if you have different players, like not everyone's gonna play aces the same way. So, like it might be the case that just because of the variance, like the noise of the sample size, then one different kinds of suits have different kinds of frequencies. So, I think that it is very possible that the data is correct and this is correct. But then because of the variances, it becomes like this. And I also realized that I downloaded the hands from the Bulldog and I took a look at them. And it seems like it is very... It seems like it will be a lot easier to parse those hands here because the format is a lot easier. Like, you can get the stacks. It just seems like it's gonna be a lot easier because of the way that it is here. And these hands have the whole cards exposed. So, like, I think all that matters is that I build the best system, and then obviously I'm thinking about I'm going to create a script to parse this as well. And then all I have to do is later on, depending on what kind of data structure I choose, because it might be this kind of format here might allow me to choose a easier data structure to analyze the hands later, but I might end up using the same. I think not, because the one that I'm using now relies on I have the actions and the rounds, so it's probably going to be a different data structure, but it shouldn't vary that much. So I'm going to do the whole process again, but to parse these hands here instead. And these ones have the whole cards, and after I do that, then all I have to do is play a bunch of different hands, so I have enough sample size to have some meaningful data out of this, and then I'll be able to build the full ranges that people have pre-flop exactly the way that they play. And if I build everything correctly, then I can also create the simulations based on... Like, and this is the part that is going to be very challenging and kind of annoying, to be honest, and I'm not looking forward to this because I know it's going to be hard. But what I will have to do is, for each single combo, I think I'm going to have to create a tree or a dictionary with the decisions of each player, I think. So for each different cards, I'm going to open up like a tree based on the bets that I select, the bets that I used most frequently, and that I put on the simulation here. Then for each one, there's going to be a frequency that the solver chooses to play against the range that I'm playing on the other side, because in one of the positions is going to be the range of the data, and the other is going to be the range that I'm selecting to play. So the solver is going to solve for that to find Nash equilibrium against the data. But then what I can do is, after I create this decision tree for each combo of each player based on the data, then I can node lock the simulations based on the decision tree that I have for each player. And then in that way, I'm going to be able to node lock all possibilities for the solver. It will be like the solver playing on my side against the data in the maximum exploitative way that it can. And then I can save those simulations and use them to train my myself. But then I also don't know if it is going to be possible to save them here, because I think you can only save the full tree and then you can only load the full tree. So I know you can save by the river, but then that's another thing, because it might get too big, the amount of variations. It is going to get very big very fast if I have to save for the turn and for the river, or actually save for the river, because it branches off obviously. So there's more combinations. Flop, there's a bunch of combinations, then the turn there's less, and then the river is all of the possible combinations. So if I have to save each specific node lock from the river, then I think it's going to get very massive here. But I think that is not a problem as long as I can create a flow of bars, let's say. Because if everything is automated, then like I can just do some rotations, let's say, of which simulations I train at each time, and I can decide based on the data that I have of my own leaks of how I can improve. Yeah, so here it saves from here. So I have to figure out, I think I will have to end up doing that, where and this is the part that is going to be challenging, because like there's a way that I'm thinking about doing, and then there's a way that they do it with the solver to navigate the tree. And I have to go based on the way that they're doing here, which involves creating the tree like this, which is going to be what I'm going to be trying to do now. Figuring out how to create an algorithm that goes from a dictionary of hands to this thing here. And the challenge is that it can change based on whether I have suited hands. I think I'm going to do, obviously it's better if I just do the more complex example first. So if I separate everything by suits instead, even if I try to do the range as isomorphic, because then all I have to do is just put create an algorithm that makes the frequency of each combo the same, and that makes them isomorphic. So an algorithm that turns the range into an isomorphic range. And it's better that way, because then I don't have to worry about, I can just get the most nuanced way, and then I can use the same algorithm for both the pre-flop ranges and the ones that I'm gonna be node locking here. So here I have to remember how to do this. Oh, in here sometimes it does this. If I click here, then it gets stuck. So yeah, I think it's here. Save small tree. No. Load tree. This is the thing that I don't understand. But I know there is some way to save the range from the river, or the simulation from the river, but I don't remember really well. Save full tree is just gonna save from the flop. That's the problem. Yeah. always forgot to put a timer here. I think I have 1.5 hours, and then I'll take a break to read something. So the other thing that I realized is that I didn't use the stack sizes, that's the effective stack and the starting pots that I get from the data here. And that is a problem because then when you save the simulation, it saves the bets based on these sizes here. Because what it's doing is getting these percentages, and then it's getting the percentage from the whatever pot you put here, and that's going to be the bet. And then it creates the tree of decisions. And this is another thing that I think I'll have to do. You just create a node and then create a tree of all possible lines based on this. And I realized that it might not be that hard because all you have to do is create a node that has all possible different options like raise, bets, check, or call. And then for each one, you just create a tree with all the possibilities, and then each path on the tree is gonna be a line. But the thing that it makes annoying as well is that you have to do it cumulative, the bets, and you also have to translate the percentages into the actual value. And it is also annoying to think about how I'm gonna, what conditions I'm gonna make to stop the tree, because then it's gonna depend on the effective stack size and the starting pot to calculate the depth of the tree, and also the boundaries between flop, turn, and river. I don't know how I'm gonna do that, because this is the tricky part that I can't think about how to do it, which is how to connect that tree with the texture of the bars, because obviously both of these things matter. You can only have the turn decisions based on the flop ones, and then it changes the board as well. So I have no idea how I'm gonna do that. And I think I'll have to do that to create the node locks. There's no other way. Fuck. Yeah, so here the bets are based on the values I have there. So I'm gonna run this stuff again. I'm also gonna limit the bets to three different bets on each street. And I know that a lot of people would say that even this is too many, and it might be. That it's probably better to just choose true bets, but I'm more curious about seeing the data and having a look, like trying to understand what are the imbalances. Yeah, so the first thing that I'm gonna do is just run this thing again, and I'm gonna print everything now instead of printing, because I was printing one by one. So I'm gonna do this stuff here, make it easier to differentiate. Flop was the other way around. Yeah. Flop. I'm not sure if this does a new line, but I'm gonna do it like this. And then I do here, here, here. Turn. River. So here, I think I'm gonna do a different dictionary to save the effective stack. And remove this from here, because there I was just doing because I was curious to see, but now I want to get the frequency, because I'm gonna do based on whatever is the greatest. So both stack size, effective stack, or stack size, or starts parameters, effective back. Starting bots. And then here I'm going to put the value and the frequency. After I do these calculations here. The other thing I realized and I fixed is that I wasn't calculating which one is in position and out of position, and that was messing up the donks because I forgot that I need to know, obviously. And also fixed this algorithm here that I had the incorrect condition here. Because before I was testing something different here. But then I realized that I need to test if the previous actions are sum 0 and the current is sum greater than 0, and if it is, then if the player is not in position, then and it is out of position, it means that if it's the first bet of the thing, and the player is out of position, which means it's a donk bet. So it depends. And then I also separated by street, which I didn't do before. And obviously, I'm only gonna call this for rounds that are either flop, turn, or river. I'm not gonna call this pre-flop. This then is just a different thing. Oh, and here the other thing that I did as well is to change the frequency by a scale, because I was thinking about, like, I want to upscale the range so that the most frequent card is 1, and then all of the other ones are upscaled in the same proportion. So let's say in the sample set it gives me 0.5, like 0.3% or 30%, the frequency of one of the cards in relationship to the whole set. Like, I want to get that from 30% to 1% to 100%. And then I want to upscale all of the other combos by the same amount, so that the range is like more, I don't know how to say it, but like it represents more, it gets closer to what would actually happen in pre-flop. Obviously, like, there's nothing I can do, I think, to make it, unless I make an assumption and I make all the hands that are played equal to 100%. And then I say that this is the range pre-flop, but then that is like, and it might be a fair assumption, because if the hands are being played, then, but it's not like, it's actually not a fair assumption, because people can either fold or 3-bet them instead of call them, or the other way around in other types of ranges. So it's not 100% fair. Which is the other thing I could have done as well, and I was thinking about doing, which is separate by line as well. But then I don't think that the data is big enough to do that, because here I think I am separating by the type of the hand it is, but I'm not separating, because the hands I have here are the ones that got into the river. So that obviously depends on the line that happened. So one thing that I could do is separate by each line. So let's say you have a line that is check raise, bet, bet. That's going to be different than check call, check, and bet, for example. And those two ranges are going to be different. And this is the thing here, is that these frequencies that I'm getting, because I don't have the data of the whole cards, are the ranges from the river. And then I'm using the ranges from the river to build the simulations here, which is not ideal. So the question is, how do you get from these ranges to the closest approximation you could have on the pre-flop range without sacrificing the data that you have, like, while still being able to represent the data for a decent amount? And then I decided that the best way to do that is to do this upscaling thing, but it didn't change much the range there, because it's separated by combos, so it's not strong enough. But the other thing that I can do is obviously turn this isomorphic as well. But I think I'm not gonna end up doing these things because I think it's way better to just do everything else, do everything based on this one. I'm gonna finish the whole process for these ranges that I already did now. But I think it's gonna be much better to just do everything for this because I have the whole cards on this one. So if I create a system that works for these ones that have whole cards, then I can do, like, then I have everything set up, and all I need to do is get a bunch of data by playing more and more hands. So ideally, I would have a feedback loop system where it's like a funnel. The hands that I get are funneled into the system, and then I create the simulations that are the perfect exploitation based on the data I have, and then I train on this data to become better at exploiting whatever imbalances the pool that I'm playing against have. And then the other thing that I'm thinking about doing as well, which I might do before I even do the no locks, is to think about a way to figure out what are the places where there is the most imbalance. And I think this is possible probably because based on the EV that it calculates there. Just create an algorithm that tests a bunch of different ranges and then gets the EV from most of them and then orders the EV based on the one that has the highest EV, and then I can create a hierarchy of importance based on what spots are the best to train first because they're the ones that are most imbalanced in relationship to what the solver would do against the players. And the only thing here is that it doesn't show which one is the turn. Oh no, this is the summary, so it does show flop turn. So it seems like it's gonna be very easy to try to turn this one into the... Because it even has the explanations here. It's much better. You have the two players, the player position, like it's ridiculously better, ridiculously easier to do it, I think. You already have the actions, pretty much everything set up already. It's even in dictionary format to build everything. But I'm gonna build the simulations first, I think, the no lock first. So here after effective stack and yeah, I think it should be before this thing here. This is the post in the blinds, then checks to see, and then increases. Yeah, I think this part, it increases the... let me think. I think in one of these functions I put the starting pot. But I can do it here as well. I don't even need to do this, actually. You just make equal to the pot size, I think. And it's gonna be... So I do the condition here, if not... Then I'll create this thing here. With this... Goes to 1. The rise increase, and then the same thing for the other one. Yeah, so I'm just gonna use the ones that are used the most. And then go here or print everything else. And here I'll get the turn. Oh, this is already the bats, so I'll get the raise. I'll do them like this. It's Ctrl D to copy the line. In PyCharm. So I'm just gonna print everything, and then I'm gonna get the three most frequently used bats to create the simulation. And now let me do this first, then I'll think about it. Bases, don'ts. They're here. Yeah, now I should have everything, I think. I'll copy this here. So after I run this, I'm gonna use all the bats to build the simulation, and then I'll do the bat sizes as a standard thing. But I think I might have to end up doing the algorithm. I'm probably gonna have to do that or to figure that out. On how to create the lines based on the bat sizes that I have there, because to node lock is probably required to. This is gonna be tough. Oh, but actually, let me think. Maybe I don't need to do that, because all I need is to have the ranges. Like, I can construct each range at each part of the game tree based on the data I have already, in the same way that I did this one. So this one is for the river. The only thing that I'll have to do is do the whole line thing. So I have to make this more sophisticated to incorporate the actual lines. And so what I will end up doing, I think, is create an algorithm to create the whole tree based on all the possible decisions, and then create an algorithm that finds the path on the tree based on the sequence of bats that I have. I think that's gonna be, and it's very similar to a red and black tree, I think, where I'm gonna have two different types. One is like one player, and the other type is the other player. And then the children that I have are the opposite ones, because it obviously goes back and forth. So it might not be that difficult to do. I think I'm gonna run this. Not sure. I think I'm not missing anything. So but it obviously it gets more complicated, so it's not. But once I have the bats, the different bats, or like the different frequency of cards based on the line, yeah, that's the thing that I need to figure out is creating an algorithm that associates the. I'm gonna have a standard dictionary, let's say. Yeah, this is what I'm gonna do. I'm gonna do all the possible permutations between ranks and suits of cards. So I have this. I create this grid here. And then based on that, for each single card, I create a frequency based on the line. So it's the calculation of the frequency that I did there, where you get the sum of all of the frequencies divided by, the frequency divided by the sum times 100. And I do that for each specific card based on the data. And then for the preflop range, I do something else, which is just based on this data that I'm gonna get, which has the whole cards. So for that one, I create another algorithm, and I just get the. Yeah, but it's gonna be very similar because I'm getting the data. The only difference, I think, is on the frequencies, where the preflop range I'm gonna make it isomorphic. But then what I can do is I'm actually thinking whether or not I do need to create the simulation then, like based on. I think I actually don't need to create the preflop simulation. That's what I'm realizing now. Because what I do need is like a map of ranges. I need a tree of ranges. That's what I need. So for each single line, I have like each frequency of decisions based on the cards. And then that works like a tree, like a decision tree of bats. And each node of the tree contains a range like this with the frequencies. And that's the node lock already. Because then I can, obviously this is not going to be balanced based on how the solver would play preflop, but is like the max exploitation approach. Because the only thing that is changing from hand to hand is the frequencies of cards. Like that's the whole point of the Nash equilibrium. Because the exploits depend on the starting position is always an imbalance already, because the whole dynamic of the game is based on the distribution of equities that each player has on each hand, each range. And what each player is trying to do is maximize the equity they have and minimize the equity that their opponent have. So naturally, the position players always have advantage over the out of position player based on the preflop ranges, and because the fact that they can act last. But then, like beyond that, and it is a symmetry that is asymmetrical because each player is going to play on each position. So although the positions are asymmetrical, it becomes symmetrical because they play at the same positions at the same frequency. It's very similar to the way that I think about identity, which is an asymmetrical symmetry, which brings us closer to paradox. Like the poker is very, very similar to the way that I think about the electromagnetic field. It's pretty much the same thing, I think. And then the difference between these is the frequencies and the space between them, which is space-time. And then Nash equilibrium is this balance of bats, which are actions that change the frequency of the ranges. So the only thing that changes in exploitation is the ranges, the construction of the ranges at each point of the node. So if I view things like that, I think I can, if I'm able to create something that gets the data and creates the ranges at each point based on the bats, the line of the bat, then I think I don't need to create a simulation here, because then I have all the node locks that I want. But actually, it's not a problem. I would say that's because I don't have mine, but I do have my ranges as well. So I can create the same thing for my range. Yeah, but then it might be better to, because I'm gonna have my imbalances too. So it might be better to create the simulation from the flop with the starting range that I have, and then only do the node locks based on the ranges that the opponents have at this point. But then that's the question, because if you change the way that you play, obviously you're going to change the data. So I'm not really sure what is the best approach. I think the best is probably starting with both of the ranges based on the data. Like I put my starting range and then the starting range that the data has. And then I solve, and then node lock. But isn't that the same thing though? That's the thing. I think it's the same thing, because yeah, that's the weird self-fulfilling prophecy as well of poker. Because if I only node lock their ranges based on the data, then it might be the case that the way that the data is just because of the way that I'm playing. That's the thing. So node locking their range is the same as node locking my range in a way. The question and the thing that I'm trying to do is figure out what are my in their imbalances to play, like what are the places where I can play differently to get more value. That's the question. It looks like this is the most used stack size, and 2.85. Oh, but that's the thing, is because I forgot that it's gonna be different based on the type of board of hand that it is. So I think I can do that as well. I also have to delete this stuff from here. So I'm gonna get the type of hand it is. I think I have a function for that. And then I can separate the bats based on what kind of board it is. I think what is easier to do now is to just separate, because I don't know if I'm gonna use this anymore. Like, I think I can run only once, and then I get the bats and I do the simulations based on them. That's the other point that I talked in the past, that I can just create the simulations with more bat sizes and then node lock for them to only use the bat sizes that I have here. In the sample, that's one way to calculate a different Nash. But the problem with this way is that I don't think is a very smart, because you're just increasing the complexity too much of each point. So it makes it harder to apply the exploits. I think simplifying is best. So I think the best way is to figure out a way to use the frequencies to show the imbalances. That's the way. But the thing is, I think that every node lock is going to be just changing the frequency. Because let's say you say that they check raise. What you're saying when you say someone check raises last is you're saying that at the turn they have different distribution of ranges based on the path of the line. That's effectively what you're saying. So if I want to use the data, is the whole thing about just getting the frequency of the ranges and then creating the solution based on that. I think that's the only thing is that I think I would have to run from the beginning because it's better to use the range that I'm going to play pre-flop. Yeah, because if I use the data to pre-flop, there's still gonna be node locks. Because the perfect decisions based on the data that they have on the pre-flop range against my range is not gonna be the distributions that they show up. So I think the best way is probably ended up being that I create the simulation based on the range that I have, the range that they have on the data. Then I solve that. I automate the process of building the tree based on these bet sizes here, which I'm gonna make standard, and then I figure out based on all of the possible ranges that the data shows that they have on future streets, then I can create this tree structure of ranges. And then I create something to automate the process of node locking each one of them based on the lines that I have there. So there's 3 components here, I think. Like I have the lines, the ranges, and then node lock. And then I'm gonna have to save the river of each one. Because if I save from the flop, then it doesn't allow me to get the node locks, I think. So I'm gonna have to figure out if there's a way to automate this process. I'll saving only. I know that I can save only from the river because I've done it in the past. I just don't remember how. Because the problem is it might be just by clicking on the range and then. Yeah, I think that's the issue. But there is a way to automate that because here it shows the line here, and in the documentation it shows it explains the node ID. So the node ID is a string that contains the line and boards. So this is the stuff that I need to create. The node ID is the thing. Is going to be the tree structure, I think. Because I can create a tree of all possible decisions and all possible cards. What makes it difficult is the effective stack and the starting pot, because that determines the size of the tree. So that's the challenge. I need to create an algorithm that creates this node ID based on the starting pot and effective size and the bets that I have here. That's what I have to do. And then once I have this, then this contains all possible situations that I'm going to have here. And then depending on the path and the data that I have, I can use the data to node lock based on the node ID. And then I can use the node ID to save the range that it's going to have here. So here, I think I would go into set strategies and node lock. And the way that I save the river in the past is just by solving from the river. So I would get this point. And then I think there's a way to copy this range here. A copy range to clipboard. And then I would do like this. And then I just paste. So this is the range from that point. And then you save. So this is the other key component that I need. Translate the grid. The first thing that I have to do, translate grid into frequencies. So the dictionary, queen, cards, then space, from June stats. Yeah, so I need to go from the dictionary to this, so I can have an algorithm to translate the grid into these frequencies. And then the second thing is to algorithm that creates all possible node IDs based on boards and lines. So I'm getting the lines that I have here, which are the actions that I have, and then the boards that I have based on the data. And then I use these two things to create this thing here, which is going to be a tree probably. And the tree contains all possible, and starting points and the fact of that. So the node ID contains all the possible actions, and the data has all the possible ranges based on the frequency. So I have to create an algorithm that gets all that combines the stuff that I already did here of getting the ranges with this of getting the bats, because I need to separate the cards. I need to get the ranges based on the bats. That's what I need to do. So it is going to be almost the same thing that I did here, but then the only difference is that I separate by street and by I get the actions, I think. The actions and the board. So this is the stuff that I think I'm missing here, which is I'm not using the board yet because I was separating everything. So I think all I need to do is combine, like I get the actions and then I translate these actions into a line, or actually I don't need to translate, I just get the actions and get the board. So what I need to figure out is just the format to structure the node. So I have each line, and so an algorithm that gets the data, translates that into a node depending on the line and the cards. And that's going to be the frequency of each hand. So I need to cache this. I need to create a dictionary of node IDs and the frequency. Yeah, but no, because it has to be another data structure, because I have to encapsulate all the frequency of all the hands. So it has to be a dictionary of dictionaries where one has the node ID and the other has all the possible combos. And the possible combos contain the frequency of the ranges. Yeah, so that's how it's going to be. Actually, it might not be that hard. It's not that it's hard, it's just that I'm confused because there's a lot of other stuff. There's a lot of different things going on, so in my mind. So what I need is like nodes IDs. Then here is going to be algorithm creates the keys. That generates IDs. And then here is going to be dictionary of cards frequencies, which is the stuff that I already did on this one to get the preflop ranges. Yeah, this dictionary is here. So I'm pretty much gonna create this stuff that I did here, but not the one. I think that the type is gonna be the outer layer because it comes before. So the type comes here, type of hand, and then it's just an extra layer here on this dictionary. On the structure of nested dictionaries should take into account the node IDs. And if I can make this one happen, then I think I have all the possible range frequencies for all the different nodes based on the lines. And then I can train Pio based on that. Train on every single possible. Start training from the preflop based on the simulation here just gonna be with the template of the bats and the pre-fault ranges based on the whole cards, and then after that I can node lock based on this algorithm here for each path, and then I can save. Yeah, the thing is I'm gonna have, oh, actually it's probably smarter to just, after I have the ranges, should just save the ranges directly and to create an algorithm. I'm gonna have to create an algorithm that takes the bats, I think. That takes the inputs here and creates the file. I think that's better. Because that way I don't need to solve, I can solve whatever, from up to whatever part I want. Which is probably gonna be the river because it's more specific. But in order to solve the river, you obviously need all the frequencies until we get to that point, I think. I'll be right back. I'm back. I think this is very tricky because there isn't a correct answer. And that's the thing that is very hard because it's very analogous to the way that I think about everything else, which is that it's like the whole problem with the scientific approach, which is that the nature of this is a self-fulfilling prophecy. Like I think poker and this thing here, it perfectly represents that, because the problem is if I use the data that I have to create the ranges, then the underlying assumption of that is that like Pio would play in the same way that I'm playing. So up to the river, there are several different nested assumptions that are being made, because like the only way for them to get at the river with that range is if they play against someone that plays like me. Because if I did different decisions, then the ranges would be different in the river for them, and the data would be different. So it has this self-fulfilling prophecy aspect to the data. So what I'm trying to clarify is, like, what I'm trying to build is how to create a feedback loop system that places the data, then uses the range to exploit, and then based on the new data, it changes the range again, if that makes sense. And this is why it's so tricky to think about it, I think. Because if I solve, like, obviously, I think I don't need to solve from the flop. I can just create something that gets all possible ranges and just solves from that point, whatever point I want, because I have the data. But then, obviously, I wouldn't have my range. So what I can do is to solve from the flop with my range against the data that I have for their range at the flop, then solve the whole thing. Then from that solution, I can go travel to each node, to whatever node that I want from that point, and get the range that I would have if I was playing like Pio. So let's say I get to the river, I solve from the flop, and then I go to this river, to the solution of how Pio would play and what range Pio would have at the river, and then I get that range for me. And then I got a different range for my players for the players that I'm playing against based on the data to put here, and then I solve from this point. But then obviously here the problem is that I wouldn't have that range because I'm not playing like Pio, and they wouldn't have their range because I would be playing in a different way, so the data would be different. So the whole question is, how do I create a system that allows me to have this feedback loop where I'm putting the data as an input, the data from the people I'm playing against, and then I'm using Pio to help me get to a better understanding of the exploits and how they're going to change over time, like how the frequency of the exploits change based on the data that I have. So the whole feedback loop system is get the data, create the simulations with Pio, train on the simulations, play a different strategy, then get the new data input again, and then keep doing like this. But the question is, how do you create what is the best way to create the exploits based on the no locks? And in my mind, it has to be from the flop, because the flop is gonna change everything else, I think. But then the issue with that is that it doesn't allow me to, because you lose a lot of data, because then it doesn't allow me to train the strategies on the turn and the river based on, that strategy will assume that they are gonna play on the GTO way in the turn on the river, even though they are imbalanced on the flop because of the range, the no lock that I put there based on the range they have. And I think I need to use the data from the turn to get the imbalances on the flop. because they're gonna show up on the flop with the same hands they had pre-flop, even if they don't, even if you make a lot of mistakes, because obviously there's no decision that was made yet. So the data is gonna show, and because the data is, the board starts on the flop, and then the actions don't matter until you get to the turn. So you have to use the ranges in the turn to determine what are the imbalances pre-flop, or what are the imbalances flop. Because only that way you're gonna be able to... Oh, actually not, if you... what matters is the line, so... because you do have the actions. Like, yeah. So what matters is the line and how to get the ranges based on the tree node. Because the data is gonna have the actions, so with the actions we're gonna know how to classify each hand based on the frequency of the actions. And this is where it gets very complicated, I think. Because then it just adds another dictionary, I think. Because here, instead of having the cards mapped to the frequency that they show up in the data, I have to map the cards based on the frequency of the line that they are played at. I think this is the reason why this is weird here. And that I feel like there's something off with the way that I'm calculating the frequency. Is because I'm not... And that's what I felt in the beginning, is that like this calculation here, I felt that it didn't represent the... it doesn't have something to do with the way that they play. Like because the only thing that this calculates is how frequently they play a hand in relationship to the whole data set of hands, of possible hands. So it doesn't say anything about the way how frequently they make decisions with the hand. I think that's what's missing here. That's the problem. I need to incorporate the lines of each hand to get something meaningful out of this, I think. Now, obviously, it's another problem because I don't have the whole cards, so I don't know where... Oh, actually... Yeah, I don't know, because then I'm only getting the data based on the stuff they get in the river with. But even if I was getting the whole cards, I think I need to incorporate the decisions here, the lines. And that's what I need to think, like how to connect the actions on that structure, that data structure. So I think the only way will probably be that each combo of cards has a dictionary instead of a number. And the dictionary represents each line that they take. But I have to think a lot more about this, because the key thing here is the data structure that I'm going to use, because I'm going to have to put something like similar to the way that it is here. And that's going to be very annoying. That's the stuff that I'm trying to avoid. Because then inside of this whole nested dictionary here, it's already a pain in the ass. I'm going to have to put all of this different stuff here. And it seems like too complicated. I think that my intuition says that there's probably another way that is a lot easier. It's just probably using a tree, I think. Like if I create the decision tree, and then I figure out how to incorporate the... Yeah, I need to figure out how to create the nodes, node IDs based on the actions and the boards. And then once I have that algorithm, then I think it becomes easier. Because if I can put that as a dictionary, then I can just... Yeah, but it still doesn't change. I think what I need to create as another class. And I create one class that has the information for the range. And then I create a dictionary of node IDs that has the... Yeah, but that wouldn't allow me to incorporate the frequency. Because each node ID here has a range connected to it. That's why I'm thinking of dictionary. So this would be one key in the dictionary, and then this would be the range associated with the key. And the range is the possible decisions. That's why I'm thinking about a class, because then the class allows me to put the cards and the decision they have. Oh, but actually this is a dictionary as well, because each card has can only have like these possible decisions. But the problem is that these decisions depend on the other decisions. That's the issue. Because here you can have these bats or this check, but then if you bet, then you can have folds or these other calls and raises. So all these decisions depend on the previous decisions. That's why it's confusing as fuck. Because this thing here is like the line of actions there that I have there. But it's a multi-dimensional, that's why it's hard. There's the bars and there's the decisions for each thing. Yeah, I think I need to create the tree structure. It's probably the best. So you create the tree with all possible actions based on the bats you have. And then the line of actions here is just navigating the tree. It's an algorithm that navigates the tree. And then you have to incorporate the bars. So there needs to be different types of nodes to capture this information, I think. Yeah, that's what I'm gonna have to do. So there's the parent, the root node, which is the flop. Then from the flop you have the decisions, which are the child nodes that contain the bats, and the bats contain the lines. So for each bat you have different actions that you can take based on the previous bats and based on whatever. So I need to figure out how to, from this, I think I'm gonna use ChatGPT for this to help me with this. But so I have the list of bats and the raises, and then from these raises I create the, from this list here I create a tree. That's an algorithm from the lists and from the flops or the bars, and that creates the node ID. But then what about the hands that represent the range? So this is a dictionary containing all possible hands. But then how do you represent the actions for each hand in the tree, in the frequency of the actions? That's the question. Oh, each node of the tree is gonna have the actions in the node. So you can just use the data to increase or decrease. So obviously the sum of the amounts is gonna be 100%. And then based on the data, you decrease or increase each action. based on the amount of times that the hand is there. So it's like updating this on real time with the data, as if the data is playing against Pile. That's where I wanna get. And then seeing what Pile does in response. Maybe it's better to draw this in SkyDraw. So I remember. I think I'll write these bats and then I will do that. So it's gonna be 24.75. Oh yeah, I have to separate this stuff into different lines. Also only getting villain bats. So the simplest thing that I can do, I think, is to just create more dictionaries here. And it's gonna be ugly because it's a lot of things. I wanna separate the frequency based on in position, out of position, and based on the line as well. Oh, I think that's in position, out of position is gonna be too complicated. Because I need to classify on the simulation here, on this get decision, whether the player is in position or out of position. So I would need to have to change this data structure here to take that into account, if it's in position or out of position. I think I'm not going to do that now because it's better to focus on creating the tree algorithm, which is the most challenging one, because I think that one is going to be... I'm probably not going to use this one anymore once I create that one, because I can just update the dictionaries based on that. Yeah, once I figure out how to connect the boards and the decisions, and then connect the ranges, the frequency of the actions, based on the hands, then I don't need this stuff anymore. I can just use that to update everything based on the data at each point. But the most challenging thing is the thing about assumptions, because like figuring out what is the best street to node lock first, because obviously when I node lock the flop is going to change the actions on the turn, and then I can compare the actions on the turn with the data that I have and see the differences. But the question is how meaningful that is, because then obviously the actions change everything. It changes the ranges on future streets. The question is, what is the best way to use the data to find the correct way to train the exploitations? Because you have imbalances as well, so it's like this self-fulfilling prophecy thing where the data shows like the symmetry in imbalances between players because they are entangled through the cause and effect relationships that create the hand between both of them. Is the same thing as left and right in politics. It's not that the middle is always the correct answer, but you're never going to be able to not have left and right, because left causes right and right causes left is the same thing. And it's exactly the same thing here in poker, where one opponent actions causes the other opponent actions and vice versa. So the moment you change one opponent's strategy, like, is entangled with the other one. And because you are part of the experiment, so how do you figure out what is the best way to update so that you train in the best way possible? And I don't know the answer. I think I'm gonna focus on creating the tree algorithm first. So the first thing that I'm gonna do here is create another thing to separate from three bats and single raise pots. Because that one makes a difference because the starting pot and effective stack size. Obviously in position and out of position makes a difference, but I don't think it's worth putting the effort to solve this now. I think it's better to figure out how to create the algorithm for the tree thing. So I think I'm just gonna separate by single raise spots and three bats. And I'm gonna do single raise spots first. Then I'll do three bats. Or I can get the same bat sizes on both of them, because it is in percentages. So maybe that's better, and I just separate the stack. Yeah, I think like there's no need to complicate this now because I'm gonna change anyway. And I'm gonna probably change everything because I'm gonna use the other data as well. So I think it's not that worth it to keep making this better now until I figure out the tree algorithm for getting the frequency of the ranges based on the data. So I need to call the function set hand type and pass the actions on the round one, I think. The name of the other one, three bats. And now I think it's correct. It's the other way around. It goes here. Yeah, now it should be. So I'm gonna create two different simulations, and I'm not gonna worry about the differentiating in position and out of position. You got the bad sizes. But I'm gonna have to think about a lot about the whole question about the self-fulfilling prophecy thing about data, because the actions you have influence the actions that you have, so that their imbalances are your imbalances in a way. So the question is, how do you find the line? And the answer, like, is you find from solving preflop based on the ranges. So from that point, everything else is gonna be. Yeah, I think that's the difference actually, because what you're trying to get is just to learn your ranges. So maybe I'm overcomplicating things. Yeah, I solve from preflop and then I just node lock their ranges. And then I create a tree, or I create the same structure for my ranges based on their ranges. But that's the thing, because their ranges are based on the way that I play. But I think it doesn't matter. It does matter, but it's probably good enough, I think, to create something that allows you to update your, because there's nothing you can do with the data that you don't have. So that's the thing. I think that's enough to create this feedback loop system where you're getting the data, because then you change the way that you play. And then if the way that you changed the data set, then you use the new data set to get the new way. So it's like you're iterating over your own imbalances based on what your current imbalances create on the data. So you're playing on an imbalanced way, and then that causes the data to be on a certain way. Then you use Pio to see how Pio would exploit the data, and then you train on that simulations that maximally exploit the. Yeah, the whole question is what streets to do if you put on all of the streets the data, or if you only. Yeah, I think that's the confusing part. It's still confusing. Because if you node lock the flop with the data you have, then it changes the turn in the river. But you're still gonna have data for the turn in the river as well. So which one do you choose? The one that you would think that is better to choose the one that is from the flop. But then that has the assumption that they're gonna play GTO on turn in the river. So it would also seem that it's better to node lock all the possible ranges with the data you have and then solve again. Maybe that's the better way. But then there's the assumption. I think that's the best way, probably. So figure out how to create the tree with all possible ranges, solve the thing from the flop, and then unlock everything with the new ranges. Because that will create different ranges for you, I think. Like, it's not... Yeah, but maybe it won't. No, I think it will. Because obviously Pyro is gonna play different. But I think doing that way will change the ranges the most in the river. The ones that you... Like, they spread from what you play now to what's optimal. It's only gonna change on the river. Because they're fixing all the decisions that they have. Which assume that you would play on a different way. So that's the risk here, I think. But I think like I said, you can't get perfect because it is a self-fulfilling prophecy anyway, so. Yeah, so it seems like in this sample is... Oh, that's weird, actually. It's saying... So there's something wrong with the way that I'm doing here. It's impossible that it doesn't have single response. Yeah, that's weird. So maybe I made a mistake here on this algorithm. Let's see. Receiving the actions. And put this here. Round 1 is supposed to be the pre-flop round, I think. Yeah. Oh, that's the... No, that's correct. Just let me think. And this part is correct, so it must be on the algorithm here. Maybe it's not reversed. I think that's the mistake. But maybe it doesn't matter. Right, it's reversed because I want to get the last. And the first element has to be the last bet that was made. And a single raise pot is when there is only one bet per flop. So let's see. Previous action is different than 0, which means it's a bet. And she's on here. Current sum. Maybe it's this condition here. I think that's probably the mistake. Because this thing was generated with the PyCharm thing. That's how it wasn't certain. But let's see. Let's say the current sum is less than 0, which is a bat, and the previous ones are 0, which means previous bat would be 0. Oh, actually, I wouldn't have previous bat. No, it would be 0 here. So it's not because it's greater. So here it's greater, but then previous bat has to be different. This would be 1. Yeah, don't see how this is wrong. Because if there are no more bats, then it would make it single spot. Oh, maybe it's because I'm calling this. No, I'm not calling this or any other instance. So what's wrong here? You can try to change this. It should be the other way. See if it changes anything. Let's do like this. Make even more clear. Yeah, maybe that was a mistake probably. And what about for the other? Because the first time that is a bat, it has to go here, I think. And then any other time is gonna have a bat here, which means that's... Or it's gonna have a call, but the call is gonna come here because then they're equal. So it's gonna pass. So if there's another bat that is greater than the one that was done before, it's gonna be a raise. And then it's gonna go here because it is a 3 bats. It still doesn't show. Oh, no. This is correct. Oh no, it's because I'm dumb. It seems a fan type because this is not gonna return anything. Yeah, that's the problem. I'm gonna leave it like that. It's probably gonna work now. But I'm gonna leave it like this just in case. And I'm gonna change the other one as well. Because this is more clear as well. It's gonna be really difficult to come up with this algorithm. I have to spend a bunch of time thinking about it. How to create this tree of node IDs with the lines. I'm gonna create a different file for this. Or maybe poker tree is less confusing. Or decision tree. Maybe range tree. So I need to get a couple of nodes, I think. So it's Barnes. And there's also this street. I think it's like this. But I can do the bats, the list of bats based on the list of bats based on the board as well. Is the same thing. Oh, it's still not working. I don't understand why. And this is, I think this is clearly single race bot. Is the effect of stack? I wrote correctly. I'm a print here, so if it's gonna give me an empty string here, and then something else here. I don't get what is wrong there. The logic makes sense to me, but there's obviously something wrong. If it's never hitting this point here. Oh, maybe it's because of the effective stack that I'm getting. Yeah, maybe it's because I'm... It's showing an empty string. Huh. So it's not the effective stack. Oh, obviously because it's not hitting this point. But the other thing, it might be that the effective stack is also incorrect here, the way that I did it. I'm just getting the stack of the hand. Maybe it is correct. Because the thing that is going to change is the starting pot, not the effective stack. For 3-bet or single race pot. It has to be this algorithm here. Maybe it's the reversed. But I don't see... Yeah, let's delete this and see if it works. It's because the way that I'm adding, maybe. This is always gonna put the bats at the end, so... And I loop from the beginning. So I loop from the first bat to the final one. So I think the reversed doesn't make any difference. It's probably more optimal to have the reversed. Because then if there was a bat, it would find. If it was a bat that was greater than the last one. Because the whole point here is to find the last bat that was made. That's why it's reversed, makes it more sensitive. Yeah, I think it's not the problem. This is not the problem. Current sum not. Hmm. Like there's no way that there's no single response here. Doesn't make any sense. Yeah, because here it seems that it's working because there are ranges when I do it like this. This is what's weird because if it was never hitting the single rate spot here, then I wouldn't have the files with the single rate spots. Like the ranges would be empty. But I know that they're not. So here it's finding a single rate spot, but there it isn't. So what's the difference? Yeah, I'm doing the shack as well. Or maybe it's this thing here. Right. That wouldn't make any sense, I think. Let me remove this anyway, see what happens. I think I put this because it was giving a problem because of the... Sometimes the players didn't have positions. But it is very weird that... Because it seems like I'm doing everything the same way. Maybe the order here. Starting pawns. And in one time it works, the other time it doesn't. There's obviously something going on. Maybe it's because here I'm getting the bat sizes first. The thing is, this function shouldn't change anything on the other one. Maybe I should run this one again, just say. The round is the same. I'm using actions. And one, actions in one. So what the fuck is going on? Or is it because it's not exactly single ray spot? Maybe confusing this. But it's the same. And here you would be printing here anyway. Once I print here. Like when it's 3 bats, it's printing 3 bats. But I know this one is working, so that's the thing. What the fuck is going on? Or maybe this one isn't working. It's just the way that I'm saving. Because I'm saving on positions. And then I'm saving based on type. So maybe this one is wrong as well. That's the thing. Yeah, but then I wouldn't be able to save them. Because it wouldn't have on the dictionary. Because I'm accessing the type here. And the numbers here. So I think it has to be correct. Because this value wouldn't exist if the type didn't exist. Let me run this again and see if it's still working. As far as I can tell, everything is the same, but for some reason here is not working. And I have no idea why. Oh, now it is failing. So maybe I changed something and I didn't realized. And the only thing that I changed here, I think, is the condition here. Let's go back to the other one and see. Did I change anything? I think I didn't change anything here. Besides this. I must have changed something because it's not working now, but it was working before. I just don't remember changing anything besides this thing here. C0. Try it again. I think I might stop here and then just debug this off stream and then come back. Yeah, if it doesn't take too much time, then I come back once I debug. I'm gonna have to spend a lot of time thinking about how to create the node algorithm. But the thing is, I want to create that only once I figure out all the bats based on the, like, I'm gonna create one standard bats for single race bots and the other for 3-bat bots. And now it's working here. Weird. Yeah, I want to focus on the other algorithm that I know that is going to be hard to do once I have the bats figured out and once I have the simulations figured out. And maybe I'll have to focus on translating this dictionary into the frequencies first. That's the other thing that I forgot I have to do. Maybe that should be, this part here should be first. Then I'll create the algorithm. Which is probably going to be a tree to connect the nodes with the decisions and the ranges. I think with these 3 components, then it becomes easy after that to create all the simulations based on the data. The only thing that I have to think about a lot is the whole self-fulfilling prophecy thing. Let me run this again, see if it works now. Like, this wouldn't be working, I think, if it didn't. Yeah. If there were no single race bots, then this script here wouldn't be working. That's the thing, because it wouldn't be saving anything. Oh, now it works. So weird. Because I just changed this thing here because it wasn't working, but maybe it's not showing anything. Yeah, now it's showing. But the effective is also not correct, probably. So maybe this is still wrong. Because it wasn't supposed to be 7 points. Oh, it's because it's not ordered correctly. That's why. So I think it is correct, actually. Because I'm not sorting based on... I have to sort here. So I should probably change the other one now. I still don't know why this works and the other one doesn't though. So I'm gonna spend some time thinking about that, I think. Because it should be the same thing. Obviously it's because of the priority, but I don't understand. Because in my mind, when I'm doing with the parentheses, I'm separating by two groups and checking to see if both of the conditions are true. Oh, it's because I did different, I think. I did equal, that's why. I didn't do different here. Yeah. Oh, but no, it has to be it has to be equal? No. It has to be different, yeah. Because this is checking for raises, that's why. But it's weird that the only reason why I changed this was because it wasn't working. So maybe there was something else that I didn't realize that I did. Or maybe it was a problem with the other script and then I confused for this one. Yeah, who knows? It's probably because I'm thinking about a lot of different things at the same time. And I think I'm gonna stop here, go eat something, and then I'll come back later. And it's gonna take a lot of time, I think. If I go all the way with this stuff, which I'm thinking about doing, then it's probably probably gonna have to divide into multiple different parts because it's gonna take a long ass time to be able to figure everything out. Which in a way I think is a good thing. And these two things here I have to just think about it more. I think this one, the path that I have to solve, I already have a path to solve, but it's still not very good in my mind. Because the issue, the way that I'm thinking is just doing experiments or changing the range, then saving the file, getting the matrix, and then doing this a bunch of times until I have a data set that I can train something on based on the inputs and outputs to map everything. Or I can create just algorithmically, just create a dictionary that represents this, and then I put a frequency of 1 and zeros for each one and save in a different file. That's probably what I'm gonna do. And then I use that to... Yeah, the question is how do I solve from the solver without having to manually solve everything. But the worst case, I just manually solve everything, or enough of them. Manually save them to map the positions of each card with the matrix, with these frequencies here. The problem is that if I do it manually, I think is not... I can't do that because there's so many. But then maybe I can pick strategic positions and then solve based on them, depending on what parts of the grid they are. The issue is that it might change the position based on which ones you put or which ones you don't put. The position of the ones in the middle, that's the problem. And now it's not working here. Oh, it's... Oh no, I have to do... for both of them. This is two different dictionaries. Yeah, I'm gonna stop here. Maybe I'll come back later and try to figure this. I'm gonna focus on these two things here now, after I get all the bats. I think I'm gonna create the two different simulations off stream. Just reduce to 3 bats each, the most frequent ones. Got the correct effective stack and starting pots and save them as simulations. Then I'm gonna save the lines there for the commands, and then I'm gonna try to figure out how to transform this dictionary into these frequencies here. And after that, I'm gonna think about how to create the tree of these node IDs here that connects the lines of the bats and the boards. And connects all of these bats and boards with the ranges here, the frequency of the ranges. And once I have that, then I can use this to update based on the data. At each node, at each point of the tree, I can update the range based on the data. And then I can train Pio based on the, to play against the ranges at each node of the tree. By figuring out how to create the commands here, to create each tree at each point based on the matrix of hands of the ranges and the bats, the possible bats. So I might come back today to focus on this. I think very likely. I'm just gonna take a break, I think. But if I don't come back, then probably tomorrow I'll come back to do it. I might just think about this off stream as well, because it might require me to just spend a bunch of time just thinking without doing anything. So I might come back tomorrow only. But yeah.